So I want to look at two other examples under this section, under finding the nth term. And this time it's not finding the nth term, but finding a specific term based on a criteria. We're going to see what we mean. So it's finding a specific term. So under this section, all we'll do is that we find the power of b, that's the second term in the binomial, and then use this power to complete the term. All right, so the example we want to look at for this one is all right, so let's see what this means now. So we want to find the term containing x to the power of 4 in the expansion of this here. Now what that means is that we have the two terms x and 2y, right? So the first thing we need to do now is find the power here, but that's easy because if it says the term containing x to the 4, that means the power here would have to be 4 because it says x to the 4. And now if this is 4, remember that because this is 10, these two powers must add to 10. So if this is 4, this has to be 6, right? So now we have the power for each term, so the only thing we need to do now to complete the term is to find the coefficient. And we know that the coefficient will be 10 choose something. And what's that something? So remember that these two numbers, so the number here and here, are always the same. So then this would be 10 choose 6. And that's really it. So all we do now is just work this out on the calculator and we get, so that's 210 at x to the 4. And both of these will be raised to the power. So 2 to the power 6, that is 64. And that's y to the 6. So just to simplify now, 64 times 210, that's 13,440 x to the 4 y to the 6. And that's it, done. Now another example, the final example that we'll look at to finish this chapter on binomial expansion is, suppose we want, instead of a term containing like x to the 4 or so on, suppose we look at this one that says to determine the term that does not contain x in the expansion of a particular thing. So that is all right. So for this one will be a little tricky, but not very tricky, right? So I want to find the term that does not contain x in the expansion of this. Now, again, let's write the two terms. So the two terms here are 8x and 1 over 2x. So if these two were just as they are with no powers at all, the x's would just cancel here, right? But we know that they're going to have some powers when we expand them. Now, if you notice here, both of these x's have the same power. So that means in the expansion, for the x to disappear, like it has here, these two will always have the same power for the x's to cancel. So for the x's to cancel, these two must have the same power. And if we look at the expansion, here's the expansion of 8. And the only two numbers that can add to give you 8 that are the same is 4 and 4. So in other words, the powers here would be 4 and 4, because remember the powers must always add to whatever you're expanding in terms of. right? And the only two numbers that are the same that add to 8 are 4 and 4. So that's the first part. Now we just need to get the coefficient, and again, it's going to be 8 shows, and this number should be the same as this number. So that's going to be 4. And that's as easy as it is. So again, on the calculator, we'll find 8 rows 4. That's 70. And now 8 to the power 4 is 4096. So that's 4096 x to the 4 times 1 over 2 to the power 4, that's 16 x to the 4. And now these will cancel. And so, let's see, I think this 16 can go into the 4096 as well. Yeah, so 16 into this one time, I'm using a calculator. I got this to be 256. So let's simplify now. 70 times 256. That's 17,920. And that is it basically. So that concludes the chapter on the binomial expansion. And as always, you can always rewatch the video, pause it as many times as you need to review, and you should be able to do any question on the binomial expansion.